Engineering Design Lab is a multidisciplinary consultancy specializing in unique and emergent mobility solutions. We have a very unique team with a multidisciplinary skill set, so not only do we have many different types of engineers and specialties, but each person individually has been selected because they have multiple specialties themselves. My name is Tomek Barchuk. I'm the founder of Engineering Design Lab. What we're working on right now is an embodiment of all those things that we do best. The Wal-Le vehicle, which stands for Wheeled Arctic Lander Low Emissions, is a proof of concept vehicle developed for the Canadian military.
As project manager for the Wal-Le Amphibious vehicle, my duties on a day-to-day basis encompass all aspects of the project, everything from configuration level design choices down to specific implementation details. A lot of my background relates to composite materials engineering. And on this project, we've had a unique opportunity to come up with some new manufacturing processes that are allowing us to create large-scale, high-performance composite structures with far less tooling and infrastructure than is normally needed.
Each wheel is on sort of a large arm that can be manipulated up and down to allow it to climb up large obstacles, such as moving from the water onto the ice. So the combination of all these moving parts is kind of part of what makes it a fun and challenging project to work on.
One aspect of the vehicle that I took on was the design of the lift arms, which are steel structures mated to carbon fiber steering knuckles attached to titanium bearings via steel bolts.
We're trying to demonstrate that an electric vehicle can perform complex missions in the high Arctic and do so in a way that not only has less emissions, but is also much gentler on sensitive Arctic landscapes. We've developed it in such a way that each corner of the vehicle, each wheel has an identical suspension system. There are very few mechanical parts. There's one suspension arm, one shock absorber, one suspension knuckle, one wheel, one tire, one motor. So it's extremely simple, way easier to troubleshoot, way easier to fix in the field, less spare parts required. Our vehicle is designed around a 48-volt architecture, which means that you can work on it without any fear of electrical shocks.
Tucked in here maybe, just in case we're not on yet.
We're not on?
Hear contactors.
So today, we are testing the vehicle at a small gravel pit outside of Elora, Ontario. We've chosen this venue because it offers a whole range of different terrain types, so we can test all the functions of the vehicle. Here we've got access to the full breadth of terrain types and obstacles that we expect the vehicle to operate in, so we can check every aspect of its function. One of the really cool aspects of this symmetrical vehicle architecture is that it allows us to do both conventional two-wheel steering in either direction, as well as four-wheel steering for an even tighter turn radius.
One of the unique advantages of this vehicle is its incredible versatility. You can go from land to water to ice and back again without a problem.
We're out here at Sailing Gravel Pit giving some of the team members some driving time to understand the real-world handling of the vehicle a little bit better, and sometimes that helps reveal things you don't normally see in the CAD and simulations. Plus, it's really rewarding to finally see the vehicle driving around after months of hard work.
One of the unique features of the Wal-Le vehicle are the articulated suspension arms. These allow us to overcome a wide variety of extreme obstacles on land, to maneuver through complex sea ice conditions, and even retract the wheels fully out of the water for efficient marine travel.
Our concept was to make an amphibious vehicle that was just as good on land as it was in the water. Wal-Le is the first vehicle of its kind. There are no electric vehicles currently operating in the Arctic. This showcases how far the technology has come and what electric mobility can do, even in the most extreme environments on the planet.
From the start of design to the end of field tests was only 13 months. I don't think we could be prouder of our team at EDL in the work that was accomplished and how everybody just pulled together to get this done. Even though this project is now over, it's just the next step in our journey here at EDL and leading on to even more ambitious things in the future.